So when you discuss this lens maker's formula, it's not only the its derivations or the numerical, but certain questions related to it will be like, something like this. If a convex lens is placed in water, what will happen to its focal length? Then it will be asked something like a convex lens suddenly behaves like a glass slab. What may be the reason? Similarly, an air bubble in water, it is of a convex shape, but it acts like a concave lens. What may be the reason? Similarly, the what will happen to the focal length of the lens if the radius of curvature is varied? A convex lens is cut into half. What happens to the net focal length? One side is made plane, that is, it is cut into vertically half. So what is the change in focal length? So such questions will be asked all related to the lens maker's formula. So let us go one by one. The first one is a given convex lens is immersed in water. So what is the effect on the focal length? So before that, you must know that before reaching the final equation 1 by f is equal to n minus 1, 1 by r1 minus 1 by r2, you had a relation like this: 1 by f is equal to n2 minus n1 by n1, 1 by r1 minus 1 by r2. Now this, when you take the lens maker's formula, the refractive index of the lens was taken as n2, the medium was taken as n1, and r1 was taken as positive for a convex lens, r2 is negative for a convex lens. For a concave lens, so convex, r1 is positive, r2 is negative. Concave, r1 is negative, r2 is positive. N2 is glass refractive index, N1 is medium's refractive index. So all these things should be kept in mind. So let us see when you immerse a convex lens of a given focal length in water. So you have to use this equation. So 1 by f in air initially. N2 is that of the glass, so you can have 1.5 minus 1, because the refractive index of air is taken as 1, refractive index of glass is 1.5. So N of air is 1, N of glass is 1.5, N of water is 1.33. So you can have 1.5 minus 1 by 1, 1 by R1 minus 1 by R2. Similarly, F focal length in water is 1.5 minus 1.33 by 1.33, 1 by R1 minus 1 by R2. See, when you immerse it in another medium, the radius of curvature doesn't vary. So when you divide both equations, 1 by f in air by 1 by f in water equals, you can cancel these things. So you have 1.5 by 1.5 minus 1.33 multiplied by 1.33. So 1.5 minus 1, so you will have 0.5 here. Okay. So this Fw will go to the numerator, so you can have Fw by Fa equals 1.33 times 0.5 divided by 1.33, so it will be 0.17. So when I divide it, you will have 1.33 multiplied by 0.5 divided by 0.17. So you have 3.91. So 3.91 F in water is equal to 3.91 times F in air. So what happens to the focal length? So focal length in water increases when you immerse a convex lens of a given focal length in, or keep it in water. So almost 4 times it increases. So this is how. So F in water is greater than F in air.